say something about Joshua's Halloween costumes.
You know what I am? A lumberjack. It's okay. There goes all my self-esteem out the window. Did you not get that reference? No.
I'm a lumberjack, I'm okay.
All day. What millennium is this from?
It's from
Yes.
the same millennium that gave us,
The computer.
yeah, and science.
Yes.
Oh, BC.
Yes.
Yeah.
I think.
Okay, so let's get started. So thanks everybody for coming. Joshua is going to be giving a practice talk for his talk at FIE coming up next week. FIE is an engineering and computing education conference. So the audience will not be PL experts. He's going to give a 12-minute talk, and then we will have time for conference questions. That is, questions that a conference attendee might ask about the talk. So try to ask the kinds of questions that Joshua might get. We can take as much time for that as we want. And then after that, we are going to offer comments on, everyone's going to have an opportunity to offer comments on the presentation. So we'll go around and offer comments. Comments should be
Wait until later.
on about the presentation and not about the research underlying the presentation. Although, of course, sometimes it's hard to make that distinction really precise. Ken?
So Sam said everyone have an opportunity to give comments, but then he clarified by saying we will go around. So everyone also has the obligation to give comments, and so
But we can say more about that.
but I just want to inform people that you will
you will be expected to help your fellow students give an excellent talk.
Right.
Okay, with that said, I will take the role of conference chair. So, thanks everyone. It's great to see everyone here this morning. Our next talk will be given by Joshua Crotts, who's going to tell us about a pedagogically focused translation pipeline.
All right, let's start. So, in this presentation, I'm going to talk to you about a new way to teach loops. But before I do that, I want to first go over the current pedagogy, the way that we currently teach loops. So, this definition I took just straight from a textbook, which just explains what a loop is. And the way they define it is that there's a while keyword with a condition and a list of statements that comprise the body. Now, this isn't exactly an incorrect definition, but the problem is that it grossly oversimplifies the model for students. That is, there are exactly two vocabulary words that a student has here, there being condition and body. So, what happens is, so students are led to believe that loops are simpler than they might be. But the problem, unfortunately, despite loops being presented as this model that is very simple, we know that students will screw up loops. Loops are hard for beginners to learn, and these are just some of the mistakes that they can make. So we know where a student will make mistakes, and the issue lies with the current pedagogy. And the issue that underpins all of this is that there's just way too much for a student to keep track of. Because a student is given this very limited vocabulary, and then they're given some examples of the syntax, and then some examples of loops, and then they're told to go and write a bunch of complicated loops, with complicated conditionals, with complicated bodies. They're thrown phrases like sentinel values and flags, whatever that's supposed to mean to a student, right? So what this means is that students are given all these pieces to a puzzle, but then no way to assemble it. So this is the issues with the current pedagogy. What we did to address that is we created a mechanical translation pipeline. And this is a step-by-step recipe for students to write correct loops from an existing recursive implementation. The overall idea is that if we tell students that, if we don't give students all these many pieces, and we can give them something that they can use to transform an existing solution. So this is the new pedagogy. And with that, I want to go through an example. So here's a problem, and this is the reason why I took this straight from a textbook is because this is a specific example of something that students are being asked to solve, linear search. The way that our students would solve it is something like this. They would write a recursive solution. So to keep track of any values between recursive calls, they're going to use accumulators. To keep track of when the recursive call should stop, we're going to use base cases. To then keep track of how the recursive calls lead towards the base case, we update the parameters to the recursive call. So with the recursive call in hand, we're going to start identifying some pieces. What are these pieces? Well, there's three of them. We have base cases, we have return values that are not recursive calls, and then we have parameters that don't change in the recursive call. So with all those pieces in hand, we're now going to start writing the loop. And here's what we do. We're going to take those accumulators that we talked about, and we're going to make those into local iterative variables. Up next, we take our base case condition, and then we make that the negated condition of a while loop. So while it's not the case that the base case is true, do something. And what do? We have the body of the loop. And this is where we're going to take our recursive calls and translate those into updating the local variables. That is, we take the parameters and those become assignment statements to the local variables. And then the last thing we do is we just return whatever value that we identified from above. So this is an example of the new pedagogy. And aside from just being a step-by-step mechanical translation pipeline, I want to explain some of its other benefits. So first of all, there's just less information thrown at the student. They're also given more of an enhanced vocabulary to go along with what they're trying to do. Second is that the instruction is very scaffolded. It's very linear, right? You have to do one step before you go to the next. Third, because our students come in knowing about how to write recursive functions, we can leverage that. We can activate prior knowledge to help them then transfer that knowledge to writing correct loops. So, we've seen the current pedagogy and its drawbacks. We've seen the new pedagogy, an example, and then its benefits. Now I want to talk about the experiments that we conducted to this end. So, every valuable experiment is backed by a valuable question. And this is the question that we asked. What we asked was, if we have students that already know how to write recursive functions, does the translation pipeline help them write correct loops? So this is the question that we asked, and then this is the experiment that we conducted. So, the experiment is a fairly standard pre-post-test format experiment where we gave them a recursive function, and then we told them, convert that into an equivalent loop. So, we had two groups, the experimental group and the control group. The experimental group intervention was just a list of slides about the translation pipeline written in Python. The control group intervention was a list of slides based on loops written in Java from a famous Java textbook. And the data that we recorded from this was only the handwritten responses. And I say only because this will become important a little bit later. So this is the structure of our first experiment. Now, here's the data from that first experiment. So we have a plot here, and the x-axis represents the pretest total. So in the pretest, we had 2 questions. Each one was graded out of 1 point. The y-axis is the post-test total. Again, 2 questions, each one's rated out of 1 point. And this diagonal here represents the line of growth. So each one of these points here represents a data point, basically the sum of the score that they got. And a point appearing above the line indicates that they grew from the pretest to the post-test. A point below the line indicates that they had a deficit. They performed worse on the post-test. And then appearing on the line means that they didn't grow at all. So what does this tell us? It says that the experimental group, those that use the translation pipeline, which are those teal triangles, those showed greater gains in post-test performance than the control group, which are these little reddish circles. And we say that because 10 out of the 12 participants in the experimental group scored perfectly on the post-test, whereas only 5 out of 10 of the participants in the control group scored perfectly. So this is the data from the first experiment. However, now I want to talk about an issue with that first experiment. Recall that there were multiple stages of the translation pipeline. What were they? You had a problem, you had a recursive solution, and then you had, and only then, you had a loop. The problem with the first experiment is that we start them off with a recursive function. We give that to them. So we're failing to test a portion of the pipeline. So what do? We conducted the second experiment. So in that experiment, we changed up the pre and the post test. We said, all right, we're going to give you a problem, and we want you to write both a recursive solution and a loop solution. So this time, the experimental group intervention stayed the same. The control group intervention changed. This time it was Python-based. We gave them a set of slides on recursion and loops by a famous Pearson textbook. And importantly, there was a distinction in the data we recorded. So instead of just recording the handwritten data, we also recorded the time to complete each section, as well as the voice recordings to emulate a think aloud study. So this is the structure of both of our experiments, with emphasis on the second. So now let's see the data that we got from the second experiment, which is largely inconclusive. So again, like the first experiment, we have a plot here, pre-test total, post-test total on the x and y axis respectively, a line of growth. And unfortunately, unlike the first experiment, we don't actually see this trend of the translation pipeline participants showing greater gains in the traditional pedagogy. So these are the results that we got from the second experiment. And what we noticed was that there was something fundamental missing from the first research question. That is, we were asking whether an effect took place. We didn't ask how that effect comes into play. So we refined our question. This time we said, all right, we want to know how does the translation pipeline help students write correct loops? And importantly, like I said, in the second experiment, we had those voice recordings. So let's take advantage of those and qualitatively analyze them. So this is how we restructured our research questions. Now I want to briefly talk about how we coded the qualitative data. So what we did was, like I said, we recorded the voices or we voice recorded all the participants, and then we coded their utterances, which were just roughly a line of the transcript, and we associated those with a phrase, for example, base case or helper function or accumulator, just based off of what they said. So that was how we coded the data, and these are just some examples of the utterances and the corresponding codes. So let's see what that data actually showed. So here we have a plot of the word count, basically just how many words that the student said. And then that's on the x-axis. On the y-axis, we have the number of units that we coded for that participant. So for example, this participant here talked about 2,000 words, and then we had about 260 units coded for them. And what we see here is that the experimental group appears to vocally engage more with the translation pipeline. And the reason why that's important is because we believe that the translation pipeline gave the students the relevant vocabulary in order to solve the problem that we gave them. So this is the data from the qualitative analysis. And finally, I want to talk about the overall contributions. So first of all, We designed the step-by-step scaffolded mechanism, translation pipeline, for writing loops from a recursive function. That's sort of the obvious thing. The second is that we did some preliminary experiments. Now, these show promise right now, and we hope that maybe future experimentation will go towards validating our research questions, maybe answering and asking different research questions that we can then explore. And finally, we say that the translation pipeline provides learners with this enhanced, enriched vocabulary for communicating about solving programming problems. And again, the reason why that's important is because if we know from the literature that think alouds are very important for helping students develop. So if we can give students this enhanced vocabulary for talking about their problems, or the problems that they're solving, we can try to move them away from this camp of spending hours debugging all those issues we saw on the second slide, and move them more into a camp of they can write the solution correct the first time. So those are my contributions. Thank you.
Okay, so now we have time for conference questions.
I do have one.
Yep.
It seems you are trying to assume that students have already known about recursion, and you are trying to teach them how to write loops.
Yes.
Yeah, but based on my personal experience, as a beginner, loops sometimes can be more intuitive than recursion, because recursion uses some kind of self-reference, and sometimes it can be difficult to write correct recursive functions. In contrast, loops can, for a loop, we know that's a sequential operation. We just execute the iterations one by one. And for example, when we want to get the sum of all elements in a loop, the first idea coming to my mind is just to traverse all of them and use a variable to hold the sum and add everything to that sum.
Sure.
And in this experiment, you only compare the two methods. The first one is that give the students a recursive solution and ask them to transform into a loop-based solution. And the second one is to start from the problem and ask them to first write a recursive one, then the loop one. And I think maybe I expect to see a third experiment that compare the performance of students. We have two groups. The first one says that we start from recursive, then to loop, and the second is to start from a loop, then to a recursion, because to me, loop is somehow simpler than recursion.
Sure, yeah. So, I mean, it just depends on what you're trying to accomplish here. What we're trying to do is deliberately focus on the transition from writing recursive functions into loops. And you know, there has been a lot of exposition done on first talking about loops and then going to recursion. That's the very dominant way to do it.
Yeah.
But this is just what we decided to focus on.
Okay.
Yep.
So in your last point here, you say that because the people who use your pipeline said more things, then you think you provided them with the vocabulary for understanding the problem. But I guess,
Go ahead.
but maybe an alternative hypothesis is just basically the pipeline has more steps. Not saying that's better or worse, but just you're saying here are more things you have to do. So maybe they just took longer because, and said more things because you just had a longer, multi-step process for them to follow. Do you have any
Right. Yeah. So I mean, first of all, it's not just about like how many words they said. It's about how many units that we coded, how many meaningful units that we coded for them.
Mm-hmm.
And what we argue is that the translation pipeline actually does provide fewer steps than the existing way to teach loops. So if I go back here, and this is only a sample of, how loops are taught,
Right.
these slides here, again, it's just a representation. That's about 40, 50 slides of exposition that I could put here, whereas the translation pipeline it has fewer steps overall than this process. Yep.
So in your second experiment, you said that you tracked how long people took to answer the questions. Did you see any meaningful differences between the control and the experimental group?
No. No, which we thought was a little surprising, but no, there wasn't a significant or a substantial difference. No. Yep.
What's the pipeline is like, okay, like I'm a student, I have this problem to solve, so I'm going to start by writing a recursive solution. And then I would assume you're thinking about the loop very much still in terms of, okay, this is the thing I'm accumulating, this is my base case.
Yes.
So what's the goal, or for as students kind of progress past the initial learning stages of taking that and not having to start by thinking about the problem recursively every time?
Yeah, so I mean, the eventual goal of the translation pipeline is to get people to just start writing correct loops, but also, importantly, writing idiomatic loops. So, for example, summing a list of numbers, we all know the conventional solution would be for x in list, just sum it or something like that, but that's something that they would learn a little bit later on once they learn about for loops, for example, like traversing over a collection idiomatically. So this is really just to get their feet in the water with how loop conditions change, how variables are updated in between loop iterations.
Yep. Sorry, so I'm just a little confused. So, are you, like the first question, are you advocating for we should be teaching students how to write loops by first teaching them how to write recursive functions and then the translation process, or just that if they so happen to already know how to write recursive functions, then we can do it this way?
It's both. I mean, so biased opinion here, teaching recursion first is I think a better way to do it. But I mean, it could go either way. We could teach them recursion first and then teach them this, or if they already know how to write recursive functions, then they can learn like this. It's admittedly a pretty small audience, as you might expect, but this is just who we're appealing to.
So just relates to the previous question, I just want to confirm what you were saying about experiment 2.
Mm-hmm.
Can you bring up that slide about the materials? So if I heard you correctly, the control group intervention in experiment 2 is a set of slides in Python that taught both recursion and loops.
Yes.
Is that correct? And that sounds like it's actually the only intervention out of all 4. Actually 3. Like the only intervention that where you actually taught students recursion, not just loops. Is that correct?
Yeah. So this is an excellent point. So the translation, and I should probably mention this in the slide and we'll talk, but in the experimental, so the experimental group intervention stayed the same for the most part, but in the second time that we used it, we did add the entirety of the translation pipeline. So we went from a problem to writing the recursive solution and then to writing the loop. Now, we don't teach them recursion per se, we just teach them the entirety of the translation process. So I do agree with what you said, that these slides do technically teach them about recursion, because the first slide is what is recursion, the function that calls itself, whereas we do not do that. And that could be something interesting to try in a future experiment, where we take out some of the preliminary exposition on writing recursive functions. Yep.
In your second experiment,
Yes.
you're asking the control group to write a recursive solution and then a loop solution.
Yes.
But why is that the control? Isn't the normal thing that people do just read the problem and write a solution with loops?
Well, because these are the students that so that's a good question. So what we could have done in this experiment is force them to write a recursive solution. I mean, we do ask them to, but there was no order imposed to, so this word then here should not be there, it should be and a loop solution, not then a loop solution. Because they were allowed to go in any order that they wanted. If they wanted to do a loop solution first, they could do that. We gave them the option to do that.
But isn't the goal just to write the loops? Why ask the control group to write a recursive solution at all?
Well, because we wanted to see their thought process in doing it. We wanted to see if they would take the avenue of writing it recursively, if that's how it came to their mind, and then writing a loop solution to that. That was the process behind it. Yeah.
So just following on from that, so I suppose in all four of these cases, the student, yeah, exactly. You talk about recursion as well as loops, like either they're provided a recursive function. Yeah.
What do you mean by what the last thing you just said? They're provided a recursive function. What do you mean by
in experiment 1, starting with a recursive function.
Yes.
Converted to an equivalent loop. So I understood that to mean in experiment 1, experimental group, you're giving them a recursive solution.
Yes.
And you're explaining to them how to go from recursive solutions to loops, and you're asking them to write a loop solution.
Yes.
What's happening in the top right quadrant?
Right here? We're asking them to do the same thing. So they're given a recursive function, and they're asking, and then we're telling them to convert it into a loop. Here, we just give them a set of slides about how loops work and how to write loops. There's no information about recursion in that quadrant.
Okay, so then I think I have the same question as the previous person, which is why, isn't the comparison about mentioning recursion when teaching loops versus not? Basically just, telling them here's what loops are, write a loop solution?
Sure, we could have had some exposition on recursion in this quadrant and just showing something that we thought of.
Well, I'm saying rather just have no mention of recursion in the control groups. Yeah.
Oh, sure. Yeah, that's...
Like the control group is, the CS 101 at my university where there's no recursion.
Right, yeah, another experiment we could do is just say, given the problem, then convert it and then write it as a loop. We could have done that, we just chose not to for this one, because we wanted to see, the capabilities of both groups writing recursive functions. That was just our thought process with it. Yeah?
I think there's some conversations we had about should I teach recursion and loops or should I teach loops and recursion? But I'm wondering let's say I've already taught all my students loops. Can I then apply this concept and say, okay, I'll work backwards using this pipeline and we'll get recursion out of it? Mm-hmm. And if so, do you think there's any merit in doing that?
So that's something that we have thought of, and it would be interesting to measure that because there is still some vocabulary that you can get from the translation pipeline that you wouldn't necessarily get from teaching loops. Now you may get that from teaching them recursion if they already, if they know recursion and they know loops, but then you try to apply the translation pipeline, you could get something out of it because then you could always guarantee a correct recursive, you could always guarantee a correct loop implementation from the recursive implementation that you have. So there is some benefit to it going that direction, but this is primarily targeted towards a CS1, CS2 audience that doesn't know about it. Yeah.
Was there some significance in experiment 1, the control group having writing Java, or it sounds like they're writing?
Yes. So I'm very glad you mentioned this. That was just sort of a design, maybe you can call it a flaw, maybe you can call it a feature, just because that was the source of where we were complaining about the I don't want to use this term lightly, the cognitive overload from the way that loops are previously taught. That was just sort of the basis of which we were going off of. So that's why in the second experiment we made everything uniform with Python. There was no other significant reason besides that.
Or just is it a fair comparison if the experimental group in experiment 1 wrote Python, which is not it was a different language than the control group wrote Java?
Right, so that could bias the result, but I don't think it caused a significant issue because we asked them like what they knew coming into the study, and everyone knew either Python or Java coming into the study.
Okay.
Yeah, I do understand your complaint, and that's one again another reason why in the second experiment we made everything uniform, and going forward that's the very obvious approach. Yep.
So you expect students to take some courses that have taught them recursion before they get to this course?
Yes, so that's the target audience with this experiment. But like Shulin was the other audience member was referring to, you could apply this backwards and see like if there are any benefits to that approach as well. But yes, the primary
is loop you go to recursion. That's I don't know if you need loop to go to recursion.
maybe you don't, right? Yeah. But that is the traditional model, going from loops and then like teaching loops first and then teaching recursion. By traditional, I mean the very widely adopted paradigm.
But that's out of your control. You mean like you cannot decide what the overall class.
Correct.
Design.
Yeah, exactly.
So
Sure. Yeah.
This is like a two-part depending on the first question, but so are you advocating that people teach recursion and then loops, or are you just saying that if they know recursion, that this is a good pipeline?
So you did not pay attention to the question that was up here.
No, that's what I'm saying.
No, I mean, like I said, I have a bias towards teaching recursion first, but this could work in either audience. Like, someone that would learn recursion first and then learns it this way, or if they already know recursion and then need to learn loops, they can learn this.
Well, then the second question is,
Yeah.
if they don't learn recursion, because I know a lot of students who only learn loops
Mhm.
and find it difficult to understand recursion, whether, I don't know, for whatever reason they
Sure.
may understand it. Do you think it's detrimental to students? Which is why I'm saying, like, are you advocating for this? Because if those students have to first learn recursion and they don't understand it, now they're kind of like blocked off from understanding loops. Since the translation pipeline is based on that understanding of recursion.
Yeah, that direction is definitely harder. It's just not what we necessarily considered with this experiment. So I guess to answer your first question, yes, I would say I'm advocating for teaching recursion first.
Okay.
Okay, is that it for
Content question.
Okay, well, let's thank the speaker again. Okay, so now we're going to have an opportunity for Joshua to receive constructive feedback.
You have a way to type it.
Find a way to take notes. I really recommend a way to take notes that doesn't involve not showing your slides on the screen, though. Paper is often.
I can do it in the notes, like on the slide.
Okay. And so we're going to do this by starting by going around, and each person will have the opportunity to say one thing. And try not to repeat something that someone else has already said, even if maybe they said it about the same thing but about a different slide.
Should we start with the most junior person, or should we start like in Hanabi with the person wearing the most colorful clothing?
What metric is that based on?
Wearing the most colorful thing. It might be me, or maybe it's not.
Or Calvin,
Or who is the most?
or Lily. Well, I'm just paint.
Or you could just pick the most junior person.
Yeah, so we'll start with
Lily.
You're also wearing the most colorful clothing.
okay, yeah, we can go around and, and then after we've gone around, people with additional feedback can give that as well.
So I really liked on the slide when you like explained the like traditional approach. I liked how you showed like all those different examples from like whatever textbook it was.
Okay, cool. Positive feedback, something new.
You're more junior than me.
We will prefer some, well,
Negative feedback.
some shit in the sandwich.
Y'all only ever give me shit. I need positivity here. Come on.
Come, you can have sandwich bread around the shit.
We can, positive feedback is fine because it,
Makes me feel good.
it indicates things that are valuable.
Yeah, don't change that.
We should keep
Don't change it.
in,
How about
thing.
phrasing it as an imperative?
Yeah.
Don't change.
Yeah,
What is it that you shouldn't change again?
the stuff where the, show all the screenshots of slides from.
Yeah, keep
textbook.
those, keep those.
Yeah, okay, so, let's keep going around,
I
this
think
way.
Calvin's the most.
Yeah.
You showed an example of a search function, linear search.
Yep.
To me, it appeared that it was not linear search. It looked like it was summing the even numbers of the list. But
Good.
Maybe tomorrow's-
Yeah, sure.
the example.
Oh, good catch, you're right. Oh
Yeah.
my God.
So I feel like that's something.
All right, then all I have to do is change the picture of the problem.
Yeah.
Because like in the book,
picture, which slide are you talking about?
I know exactly. I'm very glad you caught that. Wow.
Where?
This I should be writing linear search, not some list. Wait, no.
Some
Oh no, I didn't. Oh, okay. Just okay.
Which slide should change?
No, I'm not showing that. Shut up. I'm not. We're not looking at it. I know what the problem is. I know what the problem is. Move on.
I don't think that's the right attitude to be taking here, but, thank you for. Okay, let's just keep going.
So my comment is more of like a visual, but on the slide that Lily was talking about where you're showing like the problem with Java textbooks, I feel like you went through that a little bit fast, or maybe it wasn't like visually cued, like, oh, it's the terminology that's confusing or whatever. Like, it felt like you were just showing a lot of screenshots.
Okay. Yeah, I can look.
Are you talking about this slide before this or after
This one.
This one?
Yeah,
Okay.
that one.
Okay.
I like the Legos in the background though.
So do not remove the Legos.
In fact,
Yeah, you have to keep the Legos.
I'll wait until I get my chance. Okay, we can go to Yafei, we can go around. So the next will be Darsho and then Sujin, but let's first hear from Yafei.
Yeah, let's just go in some sort of linear order here.
Yeah, you have changed that. Can you go to next? You have changed that. No, your pipeline. Yeah.
Right? Yep.
No, the next one. You have changed that. I saw you change the highlight
yes.
so that the red part is gray. But I think every like in that whole pipeline except the highlighted part, all of them can be grayed out. You don't need to show the previous steps
Oh, okay, sure.
to keep them there.
Okay.
So what you're saying is
Yeah.
gray out more of the pipeline to focus on the parts that.
whatever is the concept. Yeah.
All right. Great talk, Joshua. Could you go ahead? Is there a slide where you explain your methodology, like what are the steps you do with the participants to get the data?
Yep. Right here?
Right.
Yep.
Okay. Right. So I see. So you do talk about the steps, but it's not on the slides. Okay. I guess if you talk about it, that's fine. Yeah.
About
what steps, how you interacted with your participants to get this data. Like here, you say you start with the recursive function and convert it to an equivalent loop.
Yeah.
But you don't mention that you show the participants certain material to do the thing.
So can I try to make that more specific?
I think I understand what you're saying, but sure.
Okay. Yes, I can. So I would suggest using the space on the slide to show a 3-frame comic strip where in the first frame, the student takes a pretest. In the middle frame, the student reads some slides. And in the third frame, the student takes a post-test.
Right, yeah, I feel like the data is all there in the slide, but the order is not clear.
Okay, I agree.
And that in fact is the format of all your experiments, both control and experimental group for both experiment 1 and experiment 2. And so maybe you can even say that ahead of time that all the experiments are of that form.
Okay.
Yeah, this is one. The control group is the one who the Java, not the
Maybe Sujin has some suggestions for how Joshua should handle audience members who ask repetitive questions without paying attention.
I'll just go die.
It's actually valuable, right? Do you think?
I asked a repetitive question because I still didn't quite understand what his answer meant. So. Because I think, obviously there's many ways to teach loops. And so I didn't quite understand if you're saying that recursion is invaluable to teaching loops and everyone should start teaching it like that, or it's just if your school is like a big recursion school, then here's a great way to teach loops. So I was just confused about that. So maybe you can make that clear on your slide.
Okay, sure, yeah.
Also, I think maybe you had a sub-question that maybe wasn't addressed, right? Which was like, during the talk, or after the talk, which was like, what if somebody is bad at recursion? Then what?
Yeah.
Are they just cooked for like loop writing, or do you have some
I'm definitely gonna like think about this type of stuff. Yes. Thank you.
My turn? Okay. Good talk, Joshua. It's amazing. And can you go to the plot which says that your pedagogy get more gains than the traditional one? Yes, this one. I think for this slide you go through it too fast so that I can follow the meaning of this plot.
Okay.
You did explain, but you explained it too hasty, and I didn't get that point. Hopefully, you can slow down a bit to talk more about what this plot means. I think that would be a good improvement for me.
You could have some things on the slide to say like, pick a particular point and say, okay, this is a experimental group. Pre-test, they got, so like pick the experimental one that's all by itself, and say this is a person who was in the experimental group, the triangle, they got a 0.4 on the pre-test, and they got a 1.2 on the post-test. And that's how to read, which means that they improved by this distance.
That's like a 0.2, not 0.4.
Oh yes, you're right.
Okay, so I want your opinion on this. So, should I have intervals of like a fourth or only half?
I think the ticks are totally fine.
Okay.
What I'm saying is, you want to like highlight this and say, over here, translation. This person had they had this score, they had this score, and then which means their increase was this much. And that's how to read the slide. And I think that would answer Shadow's. Shadow's issue.
Okay. Cool.
Josh, I got a question about this graph as well. Like, some of them are really, like, that, one of the triangles looks like it's got like a 1.9, something like.
Yes, okay.
0.97 or something.
Yeah, it's really close to 2.
Okay. So this is a phenomenon in like writing graphs called jitter. And basically like these.
You don't jitter this.
Don't jitter though.
Yeah,
Well, then these 2 points get covered up.
Yeah, that's why we jitter.
Yeah, that's why we jitter.
Cover up.
I can jitter by a smaller amount. How about that?
Okay, so that was a content question that's out of turn. And so
very
you
useful
can
because-
use the word phenomenon wrong, but you could just say that's jitter.
That's jitter.
Yeah.
I do not think this should be jittered, but,
Okay. Well, that's also not a question.
yeah, but.
So maybe and
Should
you're also
jitter
I'm also out of
changes
turn.
the semantics of the plot.
Say again?
You shouldn't even jitter if it changes the
Yeah, let's talk
semantics.
about it. Over dinner. Okay.
I think you should have like maybe more examples of what the actual translation pipeline is so that people have that in mind.
Like another, like you agree, we all agree there's one example in this talk, right?
Yes.
Okay, we'll think about.
So you're saying we should have another example?
Yeah.
Or so.
Okay.
So first of all, this and my constructive feedback is the same as much as Yafei's and Xiao's, so I don't have any feedback anymore.
Okay.
Gotta try harder.
Okay, well, so I'm gonna veto the rule for a second. Can you say what that feedback is, just for emphasis?
Also, first of all, like for the slides where you like pile on all the textbook screenshot, it was too fast. I'm not sure what you are focusing at one point.
Okay.
And the second is this graph. It took me a while to understand what you were talking about in terms of what those data points mean.
Okay.
And also about the transition, I mean the gray area thing. I mean, yeah, maybe we can
out more in the pipeline.
Yeah. To focus what you are talking about at the one point, just highlight the parameter or face value or something.
Oh, like only show the.
Yeah, only show what you did. Yeah,
only have that ungray.
Yes. Okay.
Yes, sit here so that I appear in the recording. Could you please go to the slide that shows the demographics of the students?
Like this one?
Okay, so this is supposed to be the one that shows like
Or the second?
like the background that the students come from.
Well, I don't.
There isn't a slide that says.
There isn't a slide. Do you think there should be a slide saying like what?
Or I think you can like combine it with like the steps of the study, because I didn't think like there is like an introduction about like the demographics of the students, and it is kind of important because you are conducting a study.
Okay.
I mean, demographics here, you mean?
Like CS0, CS1, CS2.
Like they have
and
taken.
also, I don't think the audience are familiar with like the prerequisites of the course.
So I think it would help it will be informative to put some information about
the students,
how you recruit the students, what are your criteria for who to pick. Yeah.
And I think the students should probably have taken 211.
That's a question for the speaker.
Okay.
I don't think taking 211 is required for this.
Okay, but I don't think I heard like the information.
Right, he didn't say
so-
anything, yeah.
Yeah.
And even if he doesn't say anything, I think there's at least room on this slide for another column.
Yeah.
In addition to the comment?
Yeah, because the comment is below, and the column is to the right, or to the left.
Oh, sure.
By
You
the
have a huge column, leftmost column, make it narrow.
Yeah. Like the prerequisites of the course, like what course it is.
This wasn't in a course.
Okay.
Yeah. So to clear this confusion up, I think it's informative to say something about it, or to show something about it.
Yeah. But I don't think it is super important to like add one extra slide.
Right,
It
right.
is
So just integrate it
somehow.
somehow. Yeah.
Yeah, you can say like the audience, target audience CS1, CS2.
Yeah.
So, can you go to the bigger version of this slide?
Yeah.
So, I think, for me, first of all, the language, like in the four center squares, the The language is sort of important, but that's not actually the most important thing. And I think, so maybe when there's a comic or whatever, so I'm not suggesting add thousands of words to this slide, but maybe if it could somehow be like these quadrants are basically like, you know, we're coding in Python and also, you know, I provided slides about my, how to do this versus we're coding in Java and I provided just generic Java loop slide. You know, something like that.
Yeah, so instead of just saying like the language of it, say like experimental group intervention and then say what the intervention was, basically?
Yeah.
Okay.
Yeah, so originally you talked about how in experiment 1, the control group slides were about loops. And in experiment 2, the control group slides were about loops and recursion.
Got it.
And that's the kind of information that Carlo wants to see on the slide.
Right. I was a little confused, and you might have said it and I missed it, but also I think that's like the most important part more than the language, so I would like center that.
And the fact that the experiment group learned the new pedagogy, they actually learned the pipeline, like the word pipeline or new pedagogy actually doesn't appear on the slide, and that's what the experiment is trying to test.
Exactly. I mean, I figured that the experimental column like saw the pedagogy and pedagogy, but it wasn't clear exactly what each group was given.
Okay.
You know.
You skipped showing.
Oh yeah.
No. Wait. Oh, you did. Oh, yeah, you did. Sorry.
Yeah. Just like one thing I wanted to, it's like if you got to the slide, I think it's a slide that like Python on it. It was talking about like, oh, here's all these like terminologies and whatnot. That the students will have to learn if they wanted to like make a loop without like recursion beforehand.
Which one? This one?
I think it's the second slide.
This one?
Yeah.
Okay.
But then like on the next slide, you start talking about all of the same things, but in like Java, right?
Okay, got it.
Yeah, so it might
Do you think I should like uniform it or something?
Yeah, like it's like the other one is like in Java as well, just to keep it consistent.
Yeah, or just change this one to be Python.
Yeah.
Because they're all terrible.
Yeah.
Okay. Emeka?
I guess this is kind of a small, great suggestion, but like, it might be helpful to like say what textbook all these examples are taken from.
Yep.
Yeah.
Yeah, so I mean, I do, so.
Or I guess like not like these examples, like the examples of like confusing syntax in like Java or Python. I guess it's just this one.
Yeah.
Okay.
Yeah.
But it doesn't say that earlier, so.
Correct. Yeah. So you think I should say it earlier?
Yeah, or just like a little like citation or whatever. Like.
Yeah. Let's just hope K. Horseman doesn't show up to this, or maybe he should show up.
Yeah, he should show up.
Yeah. Choice words for him.
So you want the citation, right? That will be yeah.
Or yeah, just I guess.
Or just like the name of the textbook and the author.
Yeah. Something. Yes.
Okay.
On this slide.
I guess or a lot of that is the thing.
Or maybe slide
characterized as a citation.
What?
The name of the textbook and the author.
Well,
yeah.
When you said citation.
On this slide or 2 slides ago?
Both.
Okay.
One on both.
Okay.
Okay. Yeah, I mean, okay, these do come from the same book, so.
Great.
Yeah. Okay. Cool.
Can I say two things? The first one's really small. There was a slide that had an arrow going across the screen about the loop index or something early on.
This one?
Yes, right,
Yep.
that one.
Mm-hmm.
And okay, this is like really small, but it goes over the I.
Okay.
And a little bit over the E.
All right.
And then
This is how you can tell that you're a PL person.
This is called variable shadowing.
And then at the beginning of the presentation, I know it's hard because you don't have that much time, but you're just setting up what the problem is with the current, with these loops and why it's complicated. And I don't know, it's kind of hard feedback, I guess, to really do anything about. But like at the time when I was hearing it, I had a sort of reaction of like maybe because like I'm not very familiar with how people teach loops in undergrad right now. So it's like if someone tells me like this is the problem, I'm kind of like maybe, but like I wouldn't really know, I guess. And so maybe it's because I'm not the right audience for this talk, but like,
yeah, I think the audience really does make a difference. But I do understand what you're saying.
Yeah, actually, I just wasn't like immediately like, right, this is like very, very clear sort of what the problem is.
Sure.
But like, I can imagine it is, but like, yeah, I'm just not maybe the right demographic for the job, so.
Well, I mean, it's possible that there could be like some citation there.
Sure.
Like,
Yeah.
here's a paper
If you
showing
can
that
find
everybody is confused.
some
about
kind
this.
of national survey of CS1 or CS2 teachers of what topic they think students have the most trouble learning, and it turns out that loops are 57% the top choice of all CS1 teachers, then I would replace the slide after this one with that pie chart.
That's what I forgot to say, but like, I think you're giving an example of a specific book and how they teach loops. And maybe that would mean more to me if I was like, oh, right, this is like a book I would also use for the course. So maybe it's true. I just feel like, at least, so I don't know if this is like a super, super popular book.
Yeah, it is. Yeah, Big Java. Yeah, I mean, we used it before.
Yeah, it is. It was very at IU in C212.
Yeah, K. Horseman's is very, very well known.
Okay.
Yes, you should go there.
So if I go, so congratulations, I don't want to change anything about what you say.
Really?
Yeah.
No way. So I took what you said to heart.
Yeah, we did. So
the first time
you're interpreting this sentence of Ken's the wrong way, Joshua.
Oh, come on. Oh, come on. I give compliments.
So this is one.
Huh? Yeah. So I just want to I feel like there could be more, the following kind of synchronization, so visual aid to help drive home your point. So one way for this happens is when you use the word accumulator for the first time, which is when you remove the pipeline, and you're saying, oh, this loop, in order to write this loop, we have to, students learn to use the accumulator and basically, so there are three phrases I forget. Accumulator is one of them that you introduced right around here. And what you spoke was great. I just want to see the word accumulator.
Okay, so I was absolutely thinking about highlighting these.
Yeah.
Highlighting these two, boxing them, saying accumulator.
Yeah, great. Yeah.
Yeah.
So when and hit down when you speak the word accumulator.
Yeah.
Or hit down when you speak the word recursive call. I forget what else you use it, right? So there's two, I think three phrases you use here. You use them verbally very well, but you want to also highlight them as you speak. Right?
Got it.
I would synchronize.
I absolutely was thinking of doing it.
Great. Yeah. And later on we're talking about one or two slides after this. I mean, just hit that once or twice. Right, when you talk about base and return and parameters, again, trying to synchronize, right? Like, oh yeah, here, right? I see highlighting on top. Also highlight the corresponding thing below.
I think that's why he has like the box.
Yeah, so
that's why I have the box.
Okay, now if you hit down again, which box is the return values and which that box is the base
color-coded.
Yeah, they're color-coded. I want to be color-coded consistently. So above is yellow.
No, well, there's like the actual the board.
Yeah. Okay.
He sees it.
I see that.
He sees it.
Those lines need to be thicker so that I can actually tell the power support more. And also, above right now there's some yellow, so there should be a corresponding yellow below. Not just also. I agree. There's something just fell out. I guess that's me. Like the cyan above corresponds to cyan below. I see that. The red above corresponds to red below. I see that. Now the yellow above should also correspond to some yellow below. Yeah.
But it is hard to see the colors.
Yeah, make the line thicker on this slide.
Yeah.
Every line.
Do what?
Make the line thicker on this slide.
Okay.
Yeah.
I would say, what is your opinion on, so like since we last spoke about 24 hours ago, I added like.
Yeah, that's great.
Yeah, that's a big improvement.
Yeah. So I have nothing to change about you speak. Yeah.
So I think the biggest thing is placing your work appropriately in context.
Whoa.
And that means, so for example, you, at the very beginning, you said something about leap,
Yes.
where by which you meant not
you being Ken, but you meant
The broader
the broader, and I think, don't say we to mean the broader CS audience unless, unless you're going to say something totally banal, like we teach computer science. And you want to be specific about the context that you're coming from, the context that you're aiming at, and this is most important. So the we is a small example of this, but this is by far the most important when you're talking about the relationship, which many people asked about, between this and recursion first pedagogy and things like that. You want to be explicit in the talk about what we're assuming about students and why we are assuming that. And the most straightforward answer there is A, we are assuming that students already have experience with writing functions that use recursion. And we are assuming that for two reasons. One, that we're doing this in the context of a second semester programming course where they already took a first semester that featured recursion. And two, that some of the students in this course, in that first semester course, did not see loops because they took a course that was that just used recursion for repetition. And that brackets entirely the question of, is recursion first good? Which is a fight that I 100% promise do not want to have with the audience. What you want to say is, we're doing this in the context of a particular course, and all of our students have already seen some recursive functions. And so we're going to leverage that knowledge for this specific pedagogical approach. Now that means that if you want to teach loops first, this pedagogy doesn't, and you haven't taught functions, this pedagogy isn't going to work. But it's okay to admit that. That is a true statement. We don't have to say that it's true, it's relevant. Those people can just try to learn from your message more broadly, but not particularly adopt this pedagogy. But be explicit about the context and where you're coming from and what this is aimed at, because people are going to want to know that, and if you don't tell them, then they're going to be unhappy.
Yeah, so it sounds like Sam is going to answer some of these questions, earlier conference questions differently, right? When you're asked, are you advocating that we switch from loops first to recursion first and then use your pedagogy? I think Sam's answer is no, I'm not advocating that, although you might benefit,
You might find something
teaching loop students about accumulators anyway.
Yeah.
Yeah, maybe that's his answer. But you're
my
the one
answer-
giving the talk, so if you want to get into a fight, we'll watch.
Yeah,
And that was sort of what I said to Shulin.
Yeah, my answer would be, personally, when I teach CS1, I like teaching recursion first. But this pedagogy works for anyone who's teaching CS2 and wants to help students and is thus working with students who've seen writing functions, including recursive functions already, and wants to help students develop a approach to writing loops correctly. So that's the most significant piece of feedback that I want to provide.
Can we?
Yeah, if people want to offer more pieces of feedback.
So So I think this kind of slips into like what Sam was saying about bracketing it with like, here's who we're talking about.
Yeah.
Is there a reason that you didn't mention IU at any point?
Not a particular reason, I just wanted to make this as general as possible. Well, okay, I guess that is a specific reason.
Yeah.
I wanted to make it as general as possible for any university that does teach recursion first to see this problem.
Sure, but
Well, there's different things that you could mention IU in. So, for example, the most standard place to mention IU is in the slide that we are looking at right now.
Well, sure, yeah. I guess what I meant was, like, my inclination would be that you should have a slide that's kind of like, here's the context in which we're doing the experiment, although, I mean, yeah, I get that you're trying to make some more general, trying to draw more general conclusions, but if you're having some slide that's like, here's the background, like we're teaching CS1 with recursion, blah, blah, blah.
Yeah.
Then I think maybe it's worth just writing like at IU there, potentially.
Yeah.
Right.
And I think you could at least do it before you introduce the study, because the study was conducted on a group of students and you want to Yeah, right.
Okay, so
enlarge investor.
Well, exactly. Because people will be wondering, like, well, where are you from? Where you're teaching people like recursion first, and it's, I mean, the flavor of you saying IU versus, some very demographically different kind of universities is different. I don't know, in what way, but it's certainly different.
So, can I ask a question?
Sure.
So, this was 13 minutes. How the hell can I compress this? Some people want me to go faster on certain things, or some people want me to slow down on certain things, excuse me. So, what can I compress? Or what can I do to speak faster on certain areas?
Skip every 13th word. So the screen right before the one with all the overlays, the one where you have some big text and a bunch of like this thing is bad, I would just delete that slide personally.
Really? Okay.
I'm not sure. Do you want to explain to me why you shouldn't or why it's there?
Well, I mean, like, why do you think should I only get rid of it for time?
No, I feel like that if your point is just kind of like loops are hard and there's a lot of, this slide. There's a lot of like problems and things that are difficult about it. Isn't that kind of what the point is of the next, like, Dan, there's a lot of stuff to know about slides.
Yeah, and I think that actually getting rid of this slide would make the transition from this slide to this slide parallel a little bit more, because they both have the heading current pedagogy.
Exactly.
Yeah. Sure, I can do that. Okay.
So the other slide that you're showing, so what's the other set of slides that we're saying has similar information?
Like all of that afterwards, spamming the.
So go,
screenshot.
This one, this one.
Got it.
I kind of like that one.
Which one?
The one with all the screenshots. The overlay one.
This one?
Yeah.
Well, it's interesting to see the different opinions about this slide. Some people love it, some people really don't like it.
Well, I guess this one is like a lot less clear about like what the actual issues are.
What the actual issue is.
Like that one clearly states like what sort of things we're talking about here. It's just like here's like a lot of information. You can't really pick out here's conditional confusion, or here's they're mutating it twice or something.
Okay.
On these slides.
Okay.
I guess this captures the spirit.
Yeah, that's what it's supposed to do. That's exactly what it's supposed to do.
Explain more than the other one.
I guess I feel like you didn't really do a good job explaining why exactly loops are hard, even with the other slide, and I feel like maybe it's better to sort of punt on that and give some concrete reference where you're like, as we all know, citation loops are hard, and then be like, see what I mean, here's 10 different pages about loop stuff, and then just move on.
These 10 different pages?
Yeah.
Okay, got it. Okay.
That's what I'm...
Sure.
Because you're like, here's a flavor, I'm not trying to really get into it, but you see what I mean.
So, a couple other high-level points. I continue to think that too much is not the conceptual point you're really trying to make here. It's not that there's too many slides that go along with Horstman's book. It's that there's not it's that it's a bunch of disconnected ideas.
Yeah.
And that that's the problem with the current pedagogy, not that that's why you have this like big pile of Legos background, and then on the next thing, the background is Lego instructions. Like that is intentional, but you don't say that, and you don't really, you certainly don't make that analogy other than in the grayed out slide backgrounds, and you don't even really say that point. You instead say that it's too much information, which is not what we really think is the problem. It's that
I'm surprised I didn't, because like I have a line here that says, a student has all these pieces to a puzzle, but no way to assemble them. I did not say that.
Yeah, you said that.
I did say that. Okay.
Okay.
I'm fairly certain I said that.
But
I get what you're saying.
Yeah, and it's not on the slide, except
Yes.
in the washed out background.
Yep.
So that's, I think emphasizing that, because that's what the pedagogy is all about.
Yes.
And then the other, thing that I think would be valuable is talking about when we show the pipeline.
Yes.
Talk about
this right here.
On the next slide.
Okay. Yep.
Talk about the loop, the slide where you have the examples, the example of the loop. Talk about the loop before you talk about the example of the pipeline.
Like.
Yeah, here. Talk about the loop before you talk about the recursive function. That is, what we're doing is we're identifying the whole thing that you're trying to say here is that we are giving people a vocabulary for identifying more different parts of a loop to give it more structure than what we were just talking about. And so the most important thing is to say, here's how we're going to divide up this loop that we want students to produce in a structured way. And then how do we produce that? We do it by taking these individual pieces from different places that we can identify. And that's and maybe we don't want to do this by starting with the loop, but what we want to emphasize is that the result, the thing on the right-hand side here, has more structure, and we've identified that there's a bunch of different concepts in the loop that go along with different parts of things, and that's what we're trying to understand.
Okay, so just to clarify what you mean, like, do you think that I should single out those components when I'm showing the loop for the first time, or should it just be the loop itself?
You should single out those components.
That's what I thought. Okay.
We've got a bunch of variables that we have an index variable. This loop has a bunch of things that you can talk about. It has an index variable. It has an accumulator.
Yes.
It has a base case. It has updates to the variables.
Yep.
We've got a bunch of things to call out, and we can identify those for multiple different loops. For example, if we take Sanat's advice about showing a second example, you would identify those in a second place as well, and see those all correspond precisely to
parts of the recursive function that we're asking students to write as well. And that's the key idea, is that loops really have all this structure. We can identify that structure and help students translate recursive functions into that structure.
Okay.
That's the high level concept. There's more things I can say. Well, other comments?
Can I ask a more PL question?
Sure.
So I guess you're really talking about taking tail recursive solutions into
Okay. Yeah.
loops? Yeah.
Okay. So this was a big debate on like between the three of us, like whether we should ever mention tail recursion at all. And our argument was that we shouldn't, just because of the audience that we're speaking to here. It's just not relevant. Because this is a recursive solution, yes, it is tail recursive, yes, but they don't really need to know that.
Well, not just that this is tail recursive, but that the methodology requires you to start with a tail recursive solution. Right?
Yes.
Not just the recursive.
So if you read the paper, it talks about how to translate from a
non-tail
general recursive solution to a tail recursive
Yes.
solution.
Okay.
Which that part is not entirely mechanical. It doesn't use like continuation passing time for this things.
Sure.
I mean, it is known how to mechanically
Yes.
translate to a tail recursive function, but
Yes.
Well, I mean certainly a continuation, but that's in
I mean, you can just defunctionalize the
Sure, yeah.
continuation. So. I mean, we teach a whole course. It's a big project. They do that.
presumably that is like not what you have in mind.
A9 is not, in fact, included in our paper.
But yes, that is absolutely something to consider, 100%.
So I don't necessarily mean like you should talk about tail recursion. I just more mean like this seems like a well, if you were like
Yes.
yeah.
No, I agree. Yes.
Yes, you need to write your function in accumulator style.
Right.
Yes.
Which is great, but yeah.
Yeah.
That's an added constraint to like what people need to know how to do.
Right.
Yes.
Yeah.
I think there is a sense in which it would be nice to deforest this research. There's a bunch of intermediate results that it would be nice to eliminate. But we haven't figured out yet how to do that. Sure.
You have a question?
Like, is it accumulator style to like require the list to not like I don't know how to say this, like I would think you would like the list you'd like pass the short whatever the like tail of the list in each time instead of
It really sucks.
Yeah, it really sucks.
You can, if you want to write, so that's how you would write this program in beginning student, certainly.
Yeah, sure.
But it involves slicing the list every time.
Which is
In Python, there's not a rest operation on lists in Python.
Yeah.
Well, I mean, the idiomatic thing to do is use slices, but actually the idiomatic thing to do is to do this and use indexes.
Well, the actual idiomatic thing is to use a for loop. But
Well, sure. But a for loop also uses indexes.
Yes.
So fundamentally, rather than people don't treat lists as inductive structure, they treat it as something that's indexed by something that has inductive structure, and then and that's what you see in both sides of this slide, is that lists are things that are indexed by the natural numbers rather than things that have inductive structure themselves. If you were working on a binary tree,
in Python, then you'd write a program that didn't have an indexing layer.
I asked the question because then when you do the translation to the for loop, like if you did it by like induction on the list or recursion on the list, and without indexing the recursive solution, then it's not as obvious, it seems to me, how you would convert that to the for loop, because then you no longer can do that in the for loop easily. I mean, I guess you would.
No, it's just as you can do. There's just one fewer variable.
It's a while loop, so you just change every.
I
mean, you just
do a silent
While you just
while something is
L equals L dot next.
Sure.
Yeah.
Like that's how you would write it in the Linux kernel. If you were working on C, in a C linked list, where the inductive structure is commonly exposed, but Python lists are not usually programmed with that way, and so it looks really funny to have list slicing at every recursive call.
But conversely, the code you started with on the left is sort of a weird recursive solution, or it's an incredibly while loop coded recursive function.
Yes, it's if your system has very strict stack limits, but does proper tail calls. So not Python. Right. There are in fact no programming languages, but C probably is the best example of a language like that, where it would turn that into those recursive calls into go-tos, but it nonetheless has a small stack. Okay, well, let's thank Joshua again.